In the last video, we looked at a program called Scale of the Universe. When you load up the program, you can zoom in and out, and it will tell you the length or the size of of whatever you want to know. So if you click on blue wire here, it will say 3 times 10 to the power of 1, or you can keep on zooming out, and you can click on, say, the Titanic. Well, in the last video, we zoomed out. In this video, we're going to zoom in. And I will write the link for this program on in the description part of this video. So in this video, we're going to zoom in. So let's start at human. So we are here at the moment. So let's zoom in. So when you zoom in, if you want to know, say, the length of well, you've got well, you can zoom in and say, if you want to know the length of an ant, an average ant, it would say 4 times 10 to the minus 3. So what does that mean? Well, jump to this. 4 times 10 to the minus 3. So, well, when you're given this is in standard form. If you want to know in normal decimal form, well, visualize this as 4 point, well, the decimal is there, 4.0, but just visualize it as the decimal being here. So now 4, well, you've got to move the decimal 3 places to the left. So hang on. So bear with me. So here you've got to move this 1, 2, 3 places to the left. So here, well, you don't need this. So here so when you're given this here, you can jump straight to this. So it would be 0.004 meters. So learn to jump straight from here. Well, from here straight to over here. Okay, so if you're given 4 times 10 to the minus 3, well, 3, you're going to need 3 zeros, but understand why. Play around with it and try and make up your own number. Let's say 8.2, and say times 10 to the minus 6, and play around with it. And it turns out that when you have minus 3, well, you're going to have 3. Well, and anyway, develop your own technique. Okay, so let's continue zooming in. So the ant is there. So you can continue zooming in here. Well, this is what I found strange. The largest bacteria is bigger than the dust mite. And if you can read up about the dust mite on here. It says that it eats your dead skin and things like that. So, well, anyway, if you want to know the size of the dust mite, click on it and it will tell you. Let's continue zooming in. Here, the average human egg is 1.2 times 10 to the minus 4. I didn't know human lay eggs. So, well, anyway, let's carry on. Here, hang on. Here you can keep on zooming in, and E. coli here, if you click on it, it will say 2 times 10 to the minus 6. So let's jump to that. 2, well, what does that mean? 2, what was it? 2 times 10 to the minus 6. So if you get given this here, well, we're gonna need, well, because I've developed my own technique, I know that there's going to be 6 zeros, so I can jump from here to this. 1, 2, 3, 4, 5, 6. So this number here will be this number meters. So again, develop your own technique here, because the 2 was here. Now the decimal is here, so it's 1, 2, 3, 4, 5, 6. See, it works. Times 10 to the minus 6. Well, anyway, learn to jump from here straight to here in one go without doing the zero thing. Okay, so hang on, let's go back to the scale of the universe. So let's continue. Oh, if you want to know what E. coli is, you've got to ask your biology teacher. Okay, so let's continue zooming in here. Hang on. Here you've got yourself some. You've got HIV virus. Again, you can ask your biology teacher. And if you continue zooming in here, your DNA, the DNA strand here is 3 times 10 to the minus 9. So hang on. So 3 times 10 to the minus 9. Remember, your DNA is like that. This number here is actually the width here. It's not the length. Okay, it's the width. Okay, well, what does this number mean? Well, because of -9, because I've got my own, I've developed my own technique. I just know that there's going to be 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then the 3 will be here. So this number here is this number here, and it's meters. So this length here is this meters wide. Okay, so let's continue zooming in. So that's your DNA strand. So if you continue zooming in here, hang on, continue zooming in here, and water. Look at this here. The water molecule here is 2.8 times 10 to the minus 10. So hang on. So 2. What was it? 2.8 times 10 to the minus. Hang on. Let me start again. I think it was 2.8. Let me double check. 2.8 times 10 to the minus 10. So 2.8 times 10 to the minus 10. Okay. So learn to jump from here to this straight away. You could do this 2.8 and then with lots of zeros, and then move the decimal like this, but it takes too long. So develop your own technique. So my eyes will zoom into here. So I know I'm going to need 10 zeros. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to stick 2, 8 here. Okay. So this here, when you look at a water molecule, it will look something like this. Okay. Again, you ask your chemistry teacher. So you often hear this H2O. Well, this H here is a hydrogen. This is a hydrogen here. Hydrogen. Again, don't worry about this. This is oxygen here, and when there's no number, it means there's one oxygen. So this is your oxygen here. Well, maybe the length here is this here. Okay, ask your science teacher, ask your chemistry teacher about this. Okay, so hang on, let's continue zooming in. So this big bit here is actually the oxygen. O, and then you got H2. Well, when you say H2, it means two hydrogen. So when you say H2, this means it's 2 hydrogen. It's not 2 oxygen. It's 2 hydrogen and then one oxygen. Well, anyway, your chemistry teacher will tell you about it. Okay. If you keep on zooming in, you see, hey, this is the hydrogen atom here. Well, when you look at an atom, you've got electrons spinning around. The yellow circles are electrons, and this is a nucleus in the middle. And then, well, it's like planets revolving around the sun. It's similar to that, but the laws that holds for all the planets, well, they don't apply to a small scale like an atom. So when you have gravity and things like that, it's not the same thing. Well, when it comes to an atom, it will follow a different set of laws. So when you have planets are very big. It's on a big scale, so it will have its own laws. But when you zoom into an atom, the laws will be different for small scales. Well, your chemistry or your physics teacher will tell you about it. Okay, so let's continue zooming in. Well, let's do. Here you've got a proton, neutron. That makes up the nucleus, the middle part of the atom. Well, your chemistry teacher will tell you more about it. So let's continue zooming in here. You've got yourself some quarks here, and up and down quarks. Well, your physics teacher will tell you more about it. If you want to know, look up particle physics or something. Well, your physics teacher will tell you more about it. Well, let's zoom in here. Well, I just want to get to the smallest thing that we know. Okay, we just think we don't know for sure yet. So let's keep on zooming in. The smallest thing, hang on, is, well, look at this here. I want a string here. Okay, well, you can't see on the screen. It's actually 1 times 10 to the minus 35. So hang on, 1 times 10 to the minus 35. Remember when I said it's in the previous video, I said it's pointless thinking of a number like 9.2 times 10 to the power of 9999999. It's just pointless, this, because the whole universe as we know it is something like, well, times 10 to the power of something like 23. I can't remember what, 23 or 32. I can't remember. Well, anyway, you only need to go up to 32. You don't need to go up to 99999. Well, the smallest thing, which is a string here. Well, you can't see it. Let me zoom out a bit. A string here. Well, this string here is not like a normal string that you and I know. It's well, you got to do string theory in order to understand it. So you got yourself an atom here. Earlier you saw an atom, which is well, you have a nucleus in the middle, and then you've got electrons spinning around. Okay. We don't actually know what this is like, so we draw it as a circle, but some scientists think it's made up of a string vibrating. So that string is, well, you got to ask your physics teacher here. Well, this string here is 1 times 10 to the minus 35. So what that means, hang on, 1 times 10 to the minus 35. So here, this is meters, okay? So that string there is this length, okay? So what that means is this. Hang on, I'm going to need 35 zeros in front of it, okay? So it's going to be this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 21, 22, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this is 35. And then I'm going to stick a 1 in there, and then meters. Okay. So that string there is this number here. Okay. But well, you don't need to go beyond minus 35 for what we an average person. Well, you don't need to go beyond minus 35, really. Okay?